Good morning, boys. What about you? Hope all of you are fine. In our last class, we had discussed some examples related to the chapter current electricity, that means circuit based question. And in today's class, I will also try to give some idea about circuit related problem and the example is from the chapter 11 current electricity. So let's just look the stain. First of all, here are two circuit diagram in the picture. I think the picture or the diagram is clear to you. In our first diagram, our first circuit, just see here, two parallel resistors are connected, R1 and R2, and again two resistors are connected in parallel here, R3 and R4. Here the voltage or battery source that giving voltage is 10 volt, or the potential is 10 volt, and the value of the resistors R1 6 ohm, R2 15 ohm, R3 6 ohm, and R4 4 ohm. These are the parameters for this circuit. And there is another circuit in this stain. In circuit B, look at here, there is a combination of resistors, resistor 10 ohm, 8 ohm, 6 ohm, here 10 ohm, 10 ohm, 11 ohm, and three keys are used here, key 1, key 2, and key 3. The voltage source is of 12 volt and internal resistance here is 1 ohm. So these are the given information. And what are the questions according to this thing? First of all, determine the value of total current for figure A. And from then question number B, from figure B, what will be the potential for 11 ohm resistance if the three keys are closed? So if the three keys are closed in this circuit, what will be the potential for this resistance, for 11 ohm resistance? This is our second question. So let's try to solve the first question according to figure A. Determine the value of total current for figure A. You have already done so many calculations. You have done so many you have practiced so many maths related to measuring related to measurement of total current of a circuit. So I think this is very easier for you, but there is a special thing to be noted here, that in this circuit, whenever you are given question or circuit based question, first of all observe the circuit very carefully. What are the parameters are given there, and what are the question are told to solve. So according to the circuit, we will try to solve the total thing. We will try to have mathematical calculation. So we have to understand the circuit first, we have to analyze the circuit first, then we will approach to our next step. So in this circuit, we have to determine the total current. So for determining total current, our first job is to determine the equivalent resistance of the circuit. And as you are seeing over here, there are four resistors, R1 R2 in parallel, and again R3 and R4 is also parallel. So what should we do over here? We will make parallel combination or equivalent resistance for this pair, and make we will try to find equivalent resistance for this pair also. Now here is if I just make some points over here in this circuit. First point is A, second point B, C, D. I have pointed all the nodes here. So boys, if you look here, if you observe here, from point A and B there are two parallel resistors. That means we can make equivalent resistance here. But if we just approach from B to C, there are two ways, from B to C and B to D. In B to C, this is a short circuit. So then B to D, this path is not effective here, because whenever current gets a short circuit, it will approach through that way, not it will not pass through any resistor, as it is getting a straight way for going, so it will go through a resistor. So here, though a combination of resistors are used here, but before that there is a short circuit way. That's why the current will pass in this way, and these resistors will have no impact in this circuit as well. So now the calculation is very clear to us. We will just take in count only R1 and R2, as the BC is short circuited. So R3 and R4 that will not be used over here. There is no use of these resistors. Then the total combination of resistor, or the equivalent resistors Rp, will be just by calculating the parallel combination of R1 and R2, and by making this we just get the equivalent resistance is 4.285 ohm, and we have got the equivalent resistance, and we know the given potential of the source. So the total current will be E divided by Rp, and that will be 2.333 amps. So the most prominent point over here is this short circuited way. If just we try to if we fail to realize this, and we just apply these resistors in we just take in count these resistors, the math will be wrong. So these points should be clear to us, and we will be very careful while doing any circuit type math. So boys, this is the solution of first question. Next, move to second question from figure B. What will be the potential for 11 ohm resistance? If the three keys are closed, what will be the potential for 11 ohm? Look here, on our circuit, three keys are used, and as they are told to be closed, so we have made is a closed path, and now we have to determine the potential for 11 ohm resistance. So the job is same here, or we have to determine the equivalent resistance first, and first we will determine the equivalent resistance. So look over here, in this portion of the circuit there are two resistors, 10 ohm and 10 ohm, and they are in series. So it will make 20 ohm. Then in this portion there is only 8 ohm resistance, we will keep it as 8 ohm, and in third branch here two resistors are in series, 6 ohm and 10 ohm, and that will make it 16 ohm, and these three branches are in parallel. And then sorry boys, 11 ohm is in series with this combination. 11 ohm is in series, and we have to notice a very important thing over here, that here internal resistance is given, so we have to bring in it count. So we have to count this one in our calculation. If internal resistance is given in any circuit, this is must to count that one in calculation. So and internal resistance is mainly connected in series with the outer circuit. So we have projected outer circuit over here, and the internal resistance is 1 ohm, and we will add this in series with the total circuit. So now this is the simplified form of our circuit, and here three parallel resistors are 20 ohm, 8 ohm and 16 ohm. By making calculation, the equivalent resistance will be 15.2 ohms, and then there is 11 ohm, there is 1 ohm, and now these trees are in series, so we will just add these trees and we will get the total resistance of the circuit will be 15.2 plus 11 and plus 1. Or you can just make a calculation of this type. Are equivalent, or the equivalent resistance of the circuit 28, 16, these are in trees are in parallel, and plus 11, this is in series, so directly we'll add these to this combination, and we will get the resistance is 15.21 ohm. And then if we just try to measure the current over here, the equation is from Ohm's law, I equals V divided by R, and we are adding these are over here small r, that means the internal resistance we are counting, these are over here, 12 divided by 15.2 plus 1. You can add smaller in here, or in calculating the equivalent resistance. This is your choice. So we will get the total current is I equals 0.740. And so in my last class I have told you that whenever in any combination of resistances are in series, they will allow to pass same amount of current through them. So as here the total current is 0.74 amps, and these three resistors are in series, so the current will be same for each resistor. That means for 15.2 ohm resistor the current will be 0.474 amps. For 11 ohm resistor current will be the same, 0.74 amp. So we have to determine the potential for 11 ohm resistors, and for determining the potential we need the specific or the relevant resistors of that branch, that is 11 ohm, and the total current or the specific current for this resistor is 0.74 ohm, and the resistance is 11 ohm. So multiplying both we get the voltage over here 8.143 volt. So in this way we just can make calculation for determining current, for determining potential. And as in this question you are told to keep the three keys are closed, but the question may arise in a form like that, here two keys are closed, one is open, or twos are open, one is remain closed. So in such kind of combination can also come in your exam, and you whenever you are practicing you will try to solve question in different ways. That means if any for example, if key 1 is closed and key 2 and key 3 is trees are remained open, so on that case the total current will be changed. The current for 11 ohm, the current for every resistors will be changed. So you just try to solve such kind of problem for different combination. So boys, this is the example related to chapter current electricity, and in my next class I will just try to approach with some other example from other subjects. In today's class there is a homework for you. This is circuit based question. There are some resistors are used over here, 8 ohm, R1 8 ohm, and there is a combination of R2 R3 and R4. The values are given: R1 8 ohm, R2 4 ohm, R2 5 ohm, R4 6 ohm. The potential of the source is 4 volt, and the internal resistance is 0.5 ohm. So what are the questions? First of all, determine the value of total current of this circuit, and then whether the current row all register be same or not. Explain mathematically. This is a homework for you. You just complete the work and submit to the comment section of this class, including your roll number, name and roll numbers. So boys, that's all for now, and hope we will meet on our next class. See, so take care and stay safe.